All right, let's look at the homework 3.8, problem number 6. All right, so this is a turkey problem, or Newton's law of cooling problem. All right, roast turkey is removed from an oven when its temperature has reached 185. So we have initial temperature. Maybe I'll start writing here. All right, so we have initial temperature. So we already know. So T of 0. Oops, sorry. That's not what I want. Right. So we already know this is T of 0. Right. And it's placed on a table in a room where the ambient temperature is 75. So this is the temperature of the surroundings. So it's a T sub S. Right. Round your answer to the nearest whole number. Right. So we can do that. Alright, so we know that by Newton's law of cooling, we know that the temperature function is temperature of the surrounding plus initial temperature minus temperature of the surrounding. Then you have an e to the kt. So k is going to be negative because it's a cooling. Right, but it says this, so another clue. So the turkey is 150 degrees Fahrenheit after half an hour, right? So 30 minutes after, we know that temperature. So we have this clue. Capital T of 30 minutes is going to be equal to 150. Right? So we can use that to find find K probably, right? So let's do that. Right, so the surrounding temperature is, let's say, 75, so we put 75 here, plus initial temperature is 185, and minus surrounding temperature is 75, right, and e to the kt, right. So if you clean that up, you're going to have 75 plus so it's a 185 minus 75 is 110 e to the kt, right? So using that, so you have f of not f of t of 30 is going to be using the formula 75 plus 110 e to the 30k, right? And then this is going to be equal to 150. So it's a 150. Right? Let's solve for, actually, maybe I should have written it differently here. I'm going to just try to write it as a K. Oh, actually, sorry. Right? E to the K times 30 here. Right? So let's try to solve for e to the K here. Right. First thing is I'm going to subtract 75 from both sides. So we have 110 e to the k and times times 30, right, is equal to 150 minus 75 is 75, right. Then I'm going to divide through by 110. So you have e to the k and times 30 is going to be 75 over 110, right? So since 75 is a multiple of 5, so you're going to have, let's see, 15. So 75 divided by 5 is 15. And 110 divided by 5 is going to be 22, right? So it's going to be, let's see, 22, yeah. So we're going to have 15 over 22, right? Then since we're trying to find e to the k first, so I'm going to get rid of that 30 by raise it to 1 over 30th power. So we end up with e to the k is equal to 15 over 22 raise it to the 1 over 30th power. All right. So we have the entire. So we have a function. Complete formula is t of t is equal to, right, you have 75 plus 110, and here e to the k, it came out to be 15 over 22, 1 over 30th, but we still have to raise it to the t, so we're going to write it like that. All right, so we are looking for a t of 60, so we can just type it into the GeoGebra and get the value. So here, actually, also here, I can probably make this guy a little bit smaller so that we can see the formula here. Right here. All right, so we have t of t is equal to 75 plus 110, and then you have 15 over 22 raise it to the t over 30, right? So, and I hit enter. All right, then we just have to find the t of 30, and I hit enter. All right, so it looks like it's actually 150, right? So is it? Let's see, maybe it's if you go to setting, and then we have, well, I can't really see the setting here. All right, so here it's a 2 decimal places, so it's going to be actually a whole number, right? So it's going to be 150, right? So it looks like this is exactly 150. So it's I'm gonna put this one 150 degrees Fahrenheit. All right, let's check the answer. All right, actually I messed it up. It's we are looking for t of 60. For some reason I put 30 there. All right, so t of 60 and hit enter. All right, so it's about the 126. All right, 26. All right, let's check the answer again. Sorry about that. All right, it came back and it looks like we got the part A correctly. All right, let's move on to part B. After how many minutes will the turkey have cooled to 95 degrees Fahrenheit? All right, so we just have to set this formula to 95. So I'm going to, let's see, so t of t is 75 plus 110, and 15 over 22, raise it to the t over 30. And then we want to set that equal to 95. All right, so let's solve. All right, subtract 75. So we have a 110, 15 over 22, raise it to the t over 30. And then 95 minus 75 is 20. All right. Then we can just divide through by 110. We get 15 over 22, raise it to the t over 30, right, is equal to 20 over 110. So it's you can just knock off the zeros, so you have a 2 over 11. And we can go ahead and apply the natural log to both sides. Maybe you can do it on the same line. All right, then we can bring t over 30 in front. So we can write it as t over 30 times natural log of 15 over 22 is equal to natural log of 2 over 11. All right, then we just have to isolate it. So we're going to multiply by 30 and then divide by natural log of 15 over 22. All right, so t is going to be equal to, all right, 30 times natural log of 2 over 11, and then divide by natural log of 15 over 22. Right, let's find that value. So bring up a GeoGebra here. All right, so we have 30 times natural log of 2 over 11, and divide by natural log of 15 over 22, right? Then hit enter, right? So it looks like, let's see, how many minutes? It's going to take 134 minutes. So let's type it in. 134 minutes. Right, let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.